Hello and welcome to the online course for PCB design using Autodesk Eagle by inQbe Innovations. Through this video, we will learn the software installation process, schematic drawing, component placing and routing, and output file generation. A simple search in Google for Autodesk Eagle will list you the Autodesk website. Go to the website and download the software according to your OS configuration. Here I am downloading the installation file for Windows option. The download is in progress. Download is complete. Now open the installation file. The installation file has been opened. Click on I accept the agreement and you can select an option for creating a desktop shortcut and install. The installation is in progress. This might take a couple of minutes. The installation has been completed. Select the Eagle software will be automatically opened after the installation process. Might again take a couple of seconds to open up the software. Software has been opened. Go to Files, New, and select a new project. On the left side of the window, the new project will be listed. You can rename it to some other convenient name. I'm naming my project as my saving it as my first project. On right clicking it, you will find many options, and on that select a new schematic file entry. You'll be redirected to a schematic entry window. First of all, we'll have to save the schematic file. Here we'll be drawing a IR2110 driver circuit schematic. So I am naming my schematic file as IR2110 circuit. So the file has been saved now. On the left, you will be seeing many tools which will help you for the easy navigation to the schematic entries. The first tool that we will be using is to add a part, which means to add a component to the schematic. By clicking that tool, you will see a window with add option. Many components will be listed in the window. So first we'll have to search for IR2110 IC. The width has to be given as in between two stars. So we'll search for star IR2110 star. But we will be shown that there is no match available since there is no library added in the existing library for IR2110. So the next step is to go to Google and search for IR2110 library for Eagle. On searching, you will find again eagle.autodesk website. On that, you will again search for IR2110 library. Hit the search button. So you will find irs.lbr by Robocop. Download that library. Again, go to the schematic file library. In the library manager, click on the available tab for the library that we have just downloaded for IR2110. So just build the library to the existing library of Eagle. The adding is in progress. Take a few seconds. You'll see that IRS has been added to the available. The addition is complete. You can see. Select on that and the use button. So that library will be using it. Go to in use tab on the top and make sure that the IRS library has been added. You see that it is added now. Close the window. So the file. Now go to add part again and search for IR2110 as we did before. Since the library is added, we will be listed the components under this library. So we can find the IR2110 listed, and from that there will be two. Now select the first one, select the one which has the pinout of the IC. I'm selecting that, I'm placing it on the schematic file. So if you want to place more ICs, then click on the mouse or else press the escape key. Now go to add part tool again. The next component that we will be searching for is resistor. So under resistors, there will be many resistors listed, and under that we will be taking the REU type, which means a European standard, and from that REU 0207 resistor we'll choose and place it on the schematic as before. The next component that we are searching for is capacitor. Similarly, you'll find the many capacitors listed, and from that we'll be selecting the C-pole EU under RCL. And placing it on the schematic file. The next component that we'll be adding to the schematic file is diode. So on the search option, give start. Giving that will be listed many diodes. From that, select 1N4004 diode. Place the diode on the schematic file. Go to add part again. On removing the entries on the search button, the whole list will be shown to you. The next component that we'll be searching for is connectors. So we'll be needing two types of connectors, 2-pin and 4-pin. So the connectors will be listed under COMMOLEX, COMMOLEX. Molex connectors. That you find 4-pin and 2-pin connectors. So the 4-pin connector will be 22, 23, 2041, and 2021 will be 2-pin connectors. There are many connectors listed, as you can see. So we will be selecting, as I said before, 2041 connector. So that is 4-pin connector. Now place it to the schematic file. So as I said before, there are many tools available which we can use. They're all listed on the left side of the window. So now I am using the rotate tool. On clicking on the rotate tool, you can rotate the components. There is a move option, group option. Group is to group some components together. So I'm grouping all the connectors and moving it. You can see plus sign on each component. So on clicking on the move button, you should move the component by keeping the mouse on the plus button. So that will help you to move. And this is a copy. You can take copies of the components. So the net option will help you connect the components. I'm connecting the components using the net option. So I'm joining the two resistors, and the resistors are connected to the IC, high input and low input, HIN and LIN. You can also search for ground option from the add button. I'm placing the ground on the schematic. The ground can be connected using the net tool. The diode, I'm moving it to the mouse to rotate the components. For you needn't go to the tool option. You can right click on the component to rotate it. So I'm joining the third pin of the IC to the diode like shown, and to the sixth pin. Placing the capacitor. So we need one more capacitor. I'm taking a copy of the capacitor, connecting it using the net tool. Again, I took capacitor and I'm connecting it to the other side of the IC. Please refer to some textbooks for the schematic circuit diagram of this IR2110 driver circuit. I'm taking a copy of the resistor now, placing it to the right side to complete the output section of the IC. Connecting the resistors to the IC using the net tool. Now we'll be requiring two numbers of 2-pin connectors at the output side of the IC. So I'm searching for COM-MOLEX as we did before. So I'm taking the 2-pin connectors from the list, placing it on the schematic file. You can complete the connections as shown. For VDD, we will also be requiring a plus 12 volt supply to the driver circuit. So I'm searching for 12 volt supply and I'm placing it on the schematic file. Now we can insert values for the resistors for each component in the schematic. I'm giving the resistor value as 100E. Similarly, I'm giving the value of resistor R2 as 100E. Capaciting the value as 10 microfarad, 25 volt. Similarly for capacitor C1, the diode will be using, the hardware is UF007, so I'm renaming it as UF4007. I'm giving the value for capacitor C2 now as 10 microfarad, 25 volt. The output side, I'm giving the resistors value as 10 ohm and 10 ohm each. So this section is now complete. Let's save the file. Now the next section that we'll be doing is the power supply section for the driver IC. For that, we'll search for a DC jack, which will be jack. I'm searching that and I'm placing the DC power jack on the schematic. The next I'm searching for is 7805 regulator IC. So just search for star 7805 and you'll be listed many ICs. From that, we'll choose apt one. Placing the 7805 also on the schematic file. We'll be requiring capacitors also on the power supply section, so I'm taking a copy of the capacitor available. The input and output sides. Now let's complete the connections using the net tool. Searching for plus 12 volt. The output side will be getting VDD, it's plus 5 volt. Placing it on the output side. Next, I have to give value to the capacitors C4 and C5. So I'm giving the value to capacitor C4 as 1000 microfarad, 25 volt. Similarly, for capacitor C5, I'm giving value as 47 microfarad, 25 volt. So my schematic entry for the MOSFET driver section is complete. So I'm just saving the file. Now we have an option in Eagle to find out if there are any errors that we have made in the schematic entries. So the tool is available in under tools option, ERC option, error check. So the errors will be listed in that window. So here we are getting 3 warnings. All the warnings, you can just go through the warning. It's first is written as supply pin com overwritten with ground. So that is just a warning. We have just renamed the com to ground. Similarly, VCC is also, we have overwritten with this 12 volt. So I'm just approving all the 3 warnings. So now we can add any nodes in the schematic file. So for that, text option is available on the tools side. I have just given the text for easy understanding, so you can improvise it. I'm just saving the file again. Now to change it to board, you can see generate or switch to board option on the top. So give yes, and that will redirect you to the board file. On the board file, you will be able to see the components that we had entered in the schematic and also a black box. Our task will be to place all the components in the black box. I'm just comparing it with the schematic entry that we have done. You can use the button on the top SCHBRD, that is schematic to board switching tool. You can switch back and forth to view any file. Next, I'm going to place each component on the board file inside the black box. So the first component that we'll be placing is DC jack J1. Using the move tool, you can move the component. Place the mouse near to the plus sign and you can move it. Now right click on the mouse to rotate the component. Go to schematic and see which is the next component. That is, the component is C4 capacitor. Find out C4 from the bunch of components given. So using the move tool again, place the capacitor next to J1, similar to the schematic entry. Now you can refresh the connections once you have placed in the box using a tool called rat's nest. So that just refreshes the connections after placing in the box. So just rotate it to place it in the correct format. The next component is IC2, that is 7805 regulator IC. Place the IC next to the capacitor. Place the IC in a way that there are no overlapping connections. The next component is capacitor C5. So moving the capacitor C5 from the bunch to the box. Refresh the connections and place it appropriately. So all the components in the power supply section have been completed. Now we'll go to the driver section. So the next component that we will be placing in the box is connector X1. So you can find connector X1, move the connector into the box, place it towards the side or end of the box. Always the connectors and DC jack are all placed on the sides of the board. So that is why I'm placing it. The next components are resistors R1, R2. I'm placing the resistors R1 and R2 into the box. Just refreshing the connections. After R1 and R2, the next component is IC1, that is the IR2110 IC. I'm placing the IC into the box. So the IC has to be placed such that the U dip comes on the top. just to refresh the connections. The numbering starts from the left side when the U is on the top side. So we can see that the resistors R1 and R2 are connected to the pins 10 and 12 of the IC. So the 10 and 12 pins come on the right side of the IC, 10 and 12. So I'm moving the resistors R2 and R1 to the right side of the IC so as to make the connection simpler. Similarly, I'm taking the connector to the right side. The next component is C3 capacitor, which is connected to the pins 9, 11 and 13, as you can see from the schematic. So I'm placing the capacitor C3 into the box. So just to refresh it, and you can see that it's connected. Just place it on the right side. The next component is C1, which is connected across 6 and 5 pins of the IC. So taking the capacitor C1. Similarly, capacitor C2, which is connected across the pins 2 and 3. Two and 3, it's connected. Now next is the diode D1 to the 6th and the 3rd pin. So you can keep it on the left side of the IC. The next components are resistors R3 and R4. These are connected to 7 and 1 pins of the IC. 7th pin, 1st pin. So you can keep it like that on the left side of the IC. And these resistors are again connected to the connectors. So keep the connectors into the box. So we have now placed all the components inside the box. Just save the file. Now the next task is to minimize the size of the board to the maximum. So I'm rearranging all the components that we have placed in the box so that it takes minimum space. The whole of the driver section, you can move it as a group. So there's a group tool available and we can move the whole of the components as a group. So the connectors, the DC jack, everything lies on the side of the box. So I'm making the box size smaller so that the board size becomes small. You can zoom it again, save the file. Now I'm going to change some layer settings. We do not actually require all the values of the components to be displayed on the board, so I'm removing the layers 27 and 28. You can just click on it and it gets removed. Press OK. So the values are all removed from the board. Now if you can check the schematic, you'll find that the capacitor C4 has value 1000 microfarad. It is usually big in size, so I'm just changing the package of the capacitor. So this will allot more space for the capacitor C4. Now let's start routing. So for routing, we'll have to change some settings on the grid. We'll change the size to mm, not mil. So 1.27 mm. The layer has to be changed to bottom layer. So we are working on the bottom layer of the PCB. So loop remove has to be unchecked, and the routing style has to be chosen, the second one. The width has to be given as 0.1.106016. Drill size also has to be changed to 0.8. Similarly, the diameter also accordingly. We'll start routing. If you click on just one point of the DC connector, DC jack connector, the yellow line will show how the connection has to be completed. So start routing it. If you click on the mouse, then the routing stops at the point. Similarly, all the other connections have to be routed. So you can see that from that point, the capacitor negative, ground, and the negative portion of the other capacitor, they're all connected. So that's how it is done in the board file also. Next we'll route the driver IC section. If you want to unroute, then click on the unroute tool. Just clicking on it will unroute the routed connections. I'm doing the routing for the driver section also. So you can see that you have to connect the VDD. So will anyways be a jumper has to be given. So I'm doing that, and in order to change the layer, click on the center button of the mouse. So the jumper wire has to be given on the top. So it has to be made very short, the jumper wire. Similarly, the 12 volt on the capacitor, we need to give a jumper wire. Now you can check for errors using the DRC tool. We have been listed one error, that is air wire. I'm routing that also. So check for errors again using the DRC. So no errors have been found. Next, we will have to give space for drilling holes. So for that there is a hole option, and the drill size has to be changed. Place the hole on the sides of the board. I'm placing on 4 corners of the board. Just saving the file once again. Just placing the namings of the components so that it is more visible. Saving it again. As we did in the schematic file entry, I'm adding text to the board file also. The layer has to be chosen. "12 volt input near to the DC jack. The input pulses is given on the connector X1. The resistors R1 and R2 are connected to 10 and 12 pins of the IC. So the pulse input is on the right side of the board. So I'm placing it near to the connector X1. So you can see that the first and the fourth pin are connected to ground. So I'm adding ground to the board. The resistors R1 and R2 are connected to HIN and LIN, that is high input and low input of the IC. So I'm giving the text name as HIN and LIN. Adding ground also. So I've named the points of the connectors in the order. Connectors X2 and X3 are connected to high side and low side respectively. So I'm adding a text again, HO, to the connector X2. And LO to the connector X3. Now we will see how to generate different types of print files from this board file. For that, and if you hide all the layers, you'll see the box becomes nil, and I'm selecting each layer, bottom, pad, wires and dimension. This is to generate the bottom file, bottom side. So we've got the bottom side of the board. I'm just naming it. is bottom side. So I have to place it on the bottom layer. So I'm selecting the 16 bottom. The ratio is 13%. Font as vector, keeping it on the. So I'm selecting 16, 17, 18 and 23 to generate the bottom side of the board. Now we'll save it. You can give print option, and in that you can save it as a PDF. I'm giving the option as save to PDF. Paper size should be A4. Orientation portrait. The scale factor should be given as 1. I'm giving black option. The output file, I'm saving it under my first project folder. So I'm naming the file as bottom side.pdf. So the file has been saved. My bottom side of the board has been generated as a PDF. Now the next file that we'll be generating is silk screen. So for that, I'm selecting top dimension and top BCC T names. That is layer 1, 20, 21 and 25. Selecting that to generate the silk screen file. So I'm saving it as a PDF. Naming the file as silk screen. Saving the file as a PDF. Now we'll generate the green mask file. Hiding all the layers now and selecting the layers 20 and 29. And saving the file. Naming the file as greenmask.pdf. That file has also been generated. Now we'll see how to generate the drill file. For that, I'm going to the layers option, unchecking the 29th layer, checking the 44th layer, that is drills. For the drill file to be generated, we'll have to generate a table. So for that, go to the ULP and select the drill legend stack. Automatically generate a table for you. Save the file again. Drill file. So we have all the 4 files, printable files generated. If we show all the layers, we can see the whole board file. Check under projects, you will see that the bottom side of the board is generated. Similarly, the drill file, the green mask file, the silk screen file, and the drill file. Thank you for watching.